Dear students, good morning. I hope I'm audible. Before we start the session, I would like you guys to please download Robot Studio. I'll be sharing a link, web link where you can from where you can download it. If you have already downloaded, it's fine. Thank you.
Good morning, everyone. Kola Naveen Kumar holds his master's in robotics. He has trained for 2 years in ABB Robot Studio for bachelor's and part-time masters using IRB 1410 industrial manipulator. One of his notable areas of work was performed in drilling operation of titanium grade 5 aerospace alloy using industrial robot arm to investigate underlying new parameters specifically for robot machining which would affect the overall performance characteristics. Currently, his research work is in artificial intelligence, especially machine learning and deep learning. Naveen has also published research articles in international Scopus Index journals in the field of robotics. He is part of the consortium created by CVRDE DRDO, already affiliated to the Jubilee Ceremonial Conference on Combat Vehicles. His current designation is Robotics Architect. He has been in the L&D field for 5 years. Over to you, sir.
Yeah, good morning, guys. This is Naveen. I hope you are audible first. Uh, Good morning, everyone. It's nice to meet you guys. This is Naveen here. Currently, I'm working as chief architect, Prag Robotics. As no, she said, yeah, I've been working on Robot Studio for a while now. My main master thesis was in robot drilling on titanium grade alloy and armored steel. Okay, but currently I switched my interest to artificial intelligence. So currently I'm mainly working on audio analysis. Okay, using deep learning. So before, what is today's agenda, guys? Okay, let me straightly jump to the point. Okay, today we are actually going to work on ABB Robot Studio. I would like to share my experience because some of your faculty have informed me that Robot Studio is part of your. I mean, you're working on a course on robotics, and you have some exposure to ABB Robot Studio. So today I would like to share my thoughts and my experience about ABB Robot Studio. What is possible, to what far you can go in ABB Robot Studio, and we would like to build a couple of simulations today. I'll explain you how to use how to jog a robot, how to program a robot using virtual teach pendant. Similarly, if time permits, I would like to go ahead with using a power pack like picking, and we'll build a simulation. Okay. I hope that's the agenda for today. Okay. Meanwhile, see, today the main thing is your faculty explained me there were some issues, while installing Robot Studio. Okay, so I would like to cover this right from basics. Okay. So firstly, I would request you to install Robot Studio in your system. Okay, this session will be spanned for around 3 hours. Okay, then half an hour we'll have a Q&A session. Okay. First, I'm sharing. I'll just share my screen so that we'll go through. First, we'll try installing the software. I'll just yeah. I hope you can see my screen right now.
Yes, sir.
Yeah. So please go to Google. I'm just doing it from scratch. ABB Robots Studio download. Okay. So you can go to the first link that appears. Okay, that is Robot Studio downloads. If you go to here, guys, you'll find the main software, that is ABB Robot Studio 2022.3.2. This is the actual current version, okay, latest update. Along with this, you will find some elements called power packs. Okay, let's not touch these right now. Okay, some other downloads we have. See, actually, we have for each and every process, we have a different power pack, like arc welding, cutting, picking, dispensing, 3D printing. All these are possible operations and can be done on Robot Studio. So those who are new to the software, please click on this option. Okay, Robot Studio 2022.3.2. Okay, Please download the tool. I'm just pasting for you again in the group. Okay. Please try downloading that, everyone. By the way, guys, this is going to be an interactive session. This is not your class. This is not a normal class. Okay, I would like you guys to respond. I would like you guys to be interactive. Okay, so this is the software. I hope you are able to find this. Any queries? Any thoughts, guys? This is the tool. Can you please start downloading that? Any trouble so far, guys? I'll just share my, yeah. Okay, so I hope you are able to download, right? Is it? Let's wait for a couple of minutes and then we'll start. I hope there are no issues with the download. How many of you have already installed it, guys, in this class, boys and girls? Yes, Sudarshan, Vijay, you have any queries? Okay, good. Others, how many of you are have already installed? Can you please just ping how many of you have already installed? Okay, guys, any issues? I hope you have installed. I mean, I hope you have downloaded. Meanwhile, I'll just walk you through the process, guys. Okay. Mostly, you won't face any issues while you're installing. Okay. Let me just share my screen. Yeah. So I've already downloaded. So it's probably present in my downloads. Okay. So this is the software, guys. This is the software ABB Robot Studio I have downloaded. I hope you can see my screen, right? My downloads. Can you please respond, guys? Can someone respond? I hope I'm audible. See, so this is my downloads page. So here, see, Robot Studio is been installed as a, I mean, it's been downloaded as a WinRAR file, okay, compressed file. So you have to first extract it. Okay. Once you extract, if you open the software, you can go to Robot Studio. At the bottom, you find an option called Setup with the Robot Studio logo. Please double click on that to start the installation, guys. This is the tool. Please install that, guys. Sorry, please, yeah, please run that program. The tool will be installed. I'm showing you again. First, I've extracted the file. Robot Studio. Robot Studio. Here under data 11, you have the application file setup. Please run this to start the installation. See, just make sure that you're connected to internet, guys, because this uses updated .NET and Visual C++, so it has to be installed or updated. So make sure you're connected to internet, everyone. Any doubts so far, guys? Anyone? Any doubts? Shivaram, Abhinav, Praneeth. Any doubts so far? Were you able to? So guys, you can either talk to me or you can even leave a message in the chat group. Okay. Good. So please install this, guys. Yeah, Yashwin, have you I mean, were you able to download it completely? Do you start the installation? Okay, guys. So if you're not having any doubts while installing, let's move on with the actual part. Okay. So first, you would have one. You would let's say you want to understand. So you've been doing ABB. I mean, robotics course. Let's try to understand what's a robot, guys. Okay. First, explain me what's a robot, guys. What do you mean by a robot? Any thoughts? This is a class where you need to interact, guys. Okay. So what do you mean by robot? You guys are already been doing the course, right? So explain what do you mean by robot? People are still joining. what do you mean by robot? See, there is no wrong answer or right answer, guys, in my class. There is just an answer. So please tell me, what do you mean by a robot in your own thoughts? Anyone? Come on, guys. Bhargav, Prem, Prashanti, anyone? Nihil, who just came. Dinesh, Bhavanesh, Harsha, Sujit. What do you mean by a robot, guys? Your own thoughts. Anyone? Vasant, Navdeep, Neil, Rohit, Prem Sai. Come on, guys. I'm not asking you an IAS question. It's a very simple. Okay, Neil, taking time for what? Installation? Okay, no problem. So my first question. So let it install. Okay, let us speak. Let us talk on the other side. Let's have a discussion on the other side. Okay, let it install or let it download or install. Let us talk about this. Okay, what do you mean by a robot? What are your thoughts about a robot?
So it's a machine created to reduce human works,
So
to
it's a
make human.
machine which is used. So again, it's a machine.
Yes.
Okay, so it's a machine. Yeah, Pranav, you want to share some thoughts? That's a good answer, Yashwin. Anyone else, guys? So Yashwin's answer was, sir, it is a machine which is used to reduce human efforts. That's a good answer. What else? What else, guys? Rohit, Sarunan, Prashanti, anyone? Satvik, a machine that works automatically and can do some tasks that a human can do. That's a good answer, Abhinav. Again, you're telling it's a machine. Good. What else? That's a good answer, guys. Abhinav, that's a good progress. Anyone else? Okay, let me share my experience. Okay, see, to perform a repeating task, that's great, Vishwanish Anand. To to perform a repeating task. Okay, so let me share you my thoughts. Okay, number one. Okay, see, generally this is very important, guys. Even before you're doing working on ABB Robot Studio, work on Industrial Robotics, it's very important to understand what is a robot and what is not a robot. Because today we are living in a world where we have human beings, smart machines, human beings, robots, machines, smart machines, and machines. So it is much more important to understand what do you actually mean by a robot. See, we human beings, okay, a robot is made from a human being, guys. Okay, you guys are artificial intelligence students, so you should know intelligence has been extracted. The artificial intelligence is nothing but a field which tries to build programs that mimics human beings. Okay, similarly, like human beings, robots have three main elements, three very important elements. The first element is sensing. Okay, let it be an industrial robot, let it be an autonomous robot, let it be a mobile robot, any robot. The first element is sensing. Okay, it can see the world around us. For example, we have eyes, ear, nose, tongue to sense the changes. Okay, similarly, a robot needs some element to understand, to see the world or to see the changes happening in the world. Okay, one such thing is a sensor. A sensor is nothing but an electronic device which can sense the changes in the environment. For example, we have cameras which mimic our eyes. Then we have proximity sensors like ultrasonic sensors, infrared sensors. Then we have cutting edge sensors like GPS, radar, lidar, and so on. Okay. So first, using sensors, you can see the world. After sensors, what is the next main thing a human being has? He can think. So the second most important thing is thinking. Once I saw what is happening in the world, the next thing is I start thinking. Okay. So this is where we have, controllers, microcontrollers, single board computers, okay, supercomputers, which can actually calculate and come up with a decision. The third main element we have is actuation or action, taking an action. Okay, either we take our action with our legs or with our mouth or with our hands. Anyways, either we walk or we talk or we hit or we write. So these are the three main things, guys. A robot should be in a position to sense the changes. Once it senses the changes, it should be able to think or make perform decision making. Finally, it should be able to act in the environment. These are the three main things that define a robot. Okay, now that is about general robotics. Okay, next, what we need to understand is, sir, what do you mean by an industrial robot? Okay, what do you mean by an industrial robot? Okay, industrial robot looks a bit different compared to all the other robots, because an industrial robot is stationary. Okay, it cannot move, or it can move only if it is put on another mobile robot. But by nature, industrial robot or industrial arm is stationary. It cannot move. Number one. Okay, an industrial robot. Okay, it can, as who's this? Yeah, as Vishwajit said, an industrial robot is created to perform repeated or mundane tasks. Mundane tasks means simple tasks which are repeated again, again, and again, like boring tasks. For example, pick and place. Let's say I want to pick 1,000 chips packets and place it on a bin. That's boring. So here what I do is I create a robot, I create an industrial arm which can pick and place those objects. Okay. So by default, how do you define an industrial robot, sir? This definition, what you see, is given by Robotics Industries Association. Okay. A robot or an industrial robot is reprogrammable. Okay, means you can actually reprogram, you can remove that existing program and you can reprogram it. Multifunctional means, see, that is the main difference between hard automation and robot. Hard automation, in the sense, if you have an automation setup, once you change the application, you have to change the entire setup. That automation setup is mainly for only one purpose. Let us say if I want to grind, or if I want to polish, or if I want to break stones, marble stones, or granite stones, the setup is meant for only for that task. That is hard automation. But here multifunctional means, just by changing little bit in the robot, you should be able to use the robot for some other application. For example, let us take an arc welding robot. If I'm able to remove the end effector, and if I'm able to remove the arc welding unit, if I'm able to create a gripper, I can actually use the same arc welding robot for pick and place. Okay. Similarly, if I can take a spot welding robot which has around 20 kgs payload, I can remove the entire setup, make some changes in the hardware, make some changes in the program. I can use it for a different application altogether. That is multifunctional, and it is designed to move materials or parts or tools through a programmed path. Such a robot is called industrial robot. One simple hint is, this kind of robot is stationary. It cannot move. It cannot move. Now see this robot and tell me, what is it mimicking, guys? Yes, Jashwan Naidoo, do you have any thoughts to share? What is this? What is this industrial robot mimicking? What does this look like? Any thoughts? Come on, guys. What is this mimicking? Anyone?
Some kind of,
Yeah, Yashwan? Some kind of?
it's making some kind of juice. It's
No,
mostly
no,
in a bar.
no. Forget about the juice. I'm asking, what is it mimicking? Mimicking now. What does it? Okay, what is it resembling?
A human hand.
Exactly, human hand. So an industrial arm is derived from a human hand, guys. Okay. So if you see, pay attention to me. Okay. If you take our arms, human being arm also. Okay. One end it is fixed. I can just show you better. One end of the arm is actually fixed to my body. Okay. Now the other end is free to perform the application. Okay. So the industrial arm also, one end it is fixed to the ground. Okay. And the other end it is able to perform some operation. Now if you take the arm, you have two objects. Okay. Till your wrist, from your shoulder start till your wrist, okay, till this part, it is called manipulator. Okay. Manipulator means it can actually manipulate or change its position in the three-dimensional space. Now the last part, your wrist, okay, this is called end effector. This is called end effector. Or what this can do is this can possibly perform some operations.
Sir, you are muted, sir. Sir, you are muted.
Okay, I hope I'm audible right now.
Yes, sir.
Yeah, so what I'm saying is, see, uh, if I'm writing exam, okay, if I'm writing exam, what is my end effector there? What do you think? Let me explain again. Okay, my arm, my complete hand has two parts. The first part until your wrist is called manipulator, which can manipulate. The second part is called wrist, which can actually perform the operation. So these are the two main parts. So for me, the end effector is my wrist, or I have a hand. I can do anything. Clear? So now for that, let us say if I'm writing an exam, what is my end effector there? What do you think? Fingers, okay. Fingers or wrist, okay. Because I no, I am writing the exam.
Sir, you are muted again, sir.
What is the element that actually my application is writing the exam? Okay, yeah, fingers or pen. Okay, both are end effectors. Let us say if I am painting, okay, if I am performing spray painting, what is my end effector? Or if I'm welding, what is my end effector? Guys, you are correct. Please go ahead. If I'm welding, what is the end effector? Anyone? So far, you are correct. Any thoughts, Yashwin or Prem Sai, Seshan, Bharat, Lavanya? You are correct. Okay, if I'm welding, what is my end effector? Oh,
Sir, the entire
yeah.
palm will play, sir,
Huh?
including and the entire palm and the fingers, the whole thing will
Okay,
be
if
played.
I'm welding, the end effector is welding gun. What is actually performing the operation? For example, if I'm holding my water bottle, what is the end effector here? My wrist is the end effector because that is performing the gripping action. Okay, so now, so with these, let us first see what are the main building blocks of an industrial robot, guys, because this is all the more very important. Okay, let me just share my screen once again. So please pay attention over here, guys. Okay, our human being, our body, okay, it has two main things. Okay, the first one, okay, these are the bones what you have. Okay, the bones what you have are can be called as links. You would have heard about it. These are rigid body elements. Okay, these cannot move on their own. So you have links. Now two bones are joined using a joint. So here you have a joint which will actually give you the required relative motion. Got it? So that is what you mean by a joint and a link. So these two are the most important components of any industrial robot. You have links which are coupled with joints which provide relative motion. Got it? So these are the two elements, guys. Now let us see the same in Robot Studio. Okay, how many of you installed Robot Studio right now? What is the status, guys? Can you please update? Okay, Vishwajit Anand update installed. Others, can you please post a message whether you've installed or not? Please, guys, once you have done that, I can proceed forward. Yeah. Please mention in the group, in the chat, guys, whether you have installed or not, one by one, please. Guys, I'll give you another 5 minutes. Please install, guys. How many are you of you are still installing? Can you please just ping me in the chat? Okay, Yashwin Prakash installing. What about others, guys? Any troubles? Sudarshan Vijay, Emur Bhavnesh, Vishwajit Anand. Any troubles while installation? Okay, great. Okay, guys, see, I would like to talk to you about few things. Okay, before we move ahead into robot studio. Okay, so I hope this concept is clear, guys. See, industrial robot, you have only two main things, guys. Never ever ever forget, these are the foundations. Okay, you have two elements, like your bone, like your arm. You have only two elements. The first one is a link, as said, which is rigid. If you don't have a joint here, you cannot do anything with the link with your bone. So between two bones, you have a joint. Now this joint can achieve relative motion. Okay, so what are the two main components of an industrial robot? Links and joints. That's it. Okay, now before we go to robot studio, I would like to explain few things. Okay, different types of programming we have when it comes to robots. Okay, first of all, why do you need a simulation software, guys? What do you mean by simulation, guys? What do you mean by simulation? Any thoughts? Anyone? You will be pakka, you will be really good at this. You can answer. What do you mean by simulations? Anyone?
Sir, instead of doing it physically, we are doing it virtually.
Okay, instead of doing it physically, we are doing it virtually. Good, Ashwin. But why should we do that? Why should we do something? Why can't I do physically? Why should I first do it virtually? What you gave is correct. What the answer you gave is correct. But tell me, why should you do it virtually when you can do something physically?
So one answer is when the physical equipment is not available, we do it virtually.
Okay, sometimes physically the component might not be available. Okay, that's a good answer. But guys, see, simulation means it you are creating a virtual environment of the existing problem. You're trying to replicate a phenomena in nature. Okay, in the nature you have some phenomena occurring that you're trying to create virtually. For example, cyclones. Okay, air crash investigations. Why do they do air crash investigations? Huh? Why do they do air crash investigations? Is it fun or is there any reason?
To basically understand the root cause of that particular accident.
Exactly. Air crash investigation. Now it is used to understand what actually went wrong in that flight. Why was there an accident in that flight? That is one. The second thing is, if you go to any company like Audi or Mercedes, you would find car crash tests. What do you do that in that car crash tests? You actually have a real car, real Audi. Inside that, you will have a dummy. Okay, dummy which has all our conditions. Okay, human conditions. You will have the same sensing abilities of a human being. Okay, a dummy will be fit into the car. It will be having a seat belt. You take the car and you hit it to the wall with great velocity. Why, sir? Those such instances are created to understand the effect of the impact on a human being when a car is traveling at high speeds. But every time I cannot crash a car. Okay. Similarly, to investigate an air crash, I cannot crash a brand new plane also. So what I try to do is I try to create the same environment inside my computer, and then I try to create a model of my car or plane in my computer, and I'll try to create the same environment. What was the wind speed? What is the friction? What everything. And under those circumstances, I try to understand the phenomenon. That is what you call, that is what you mean by simulation. That is the importance of that simulation. Okay, and the highest paid engineers in the market are simulation engineers. Highest paid people are simulation engineers, because it is really difficult to copy something occurring in the nature, because there are many parameters you might miss out. So whatever is happening in the nature, you have to grasp that, replicate that in your system. That is why simulation engineers are highly paid. Okay, now we spoke about simulations. Now ABB Robot Studio is one such simulation software used to simulate ABB robots. I mean, any operations that involve ABB robots. Now, to give you a small motivation, I can explain you what all we can do in ABB Robot Studio. Okay, to be honest, we made many crazy projects, guys. Okay, some of the crazy projects would involve, some of the crazy projects would involve creating making a robot cell which has which can create dosas, or a work cell where a robot can actually pick and place samosas, bake cakes. Okay, so we have many such entities. Let us see them one by one. Okay, I'm just showing you some before the installation completes. I want to show you what all are possible in this. Okay, I'm just showing you. I hope you can see the screen. This is a simple work cell, okay, which we created, which will emulate the process of welding. Okay, this is where you're actually creating a work cell, okay, where a robot is performing welding. Okay, similarly, I can show you one more work cell. This is a simple pick and place work cell, guys. All these are actually created by our students. Okay, so this is a machine tending operation where you have a CNC machine and you have some objects to be machined. Okay, I'll just increase the size for time sake. I'll just, you can see a robot. Okay, actually, it what it will do is it will pick up the objects from one end. Okay, so you can see the entire operation. So I am playing it. Object is being picked, placed inside the CNC machine. The robot comes out. Then it actually closes the door. Okay, slowly the robot actually closes the door. So what I try to do is I try to emulate the object. Now see what I'm showing you the power of ABB Robot Studio. Okay, so now what happens is it will pick a new object. It will again go open the door using its fingers. You can see the gripper closing. It will open the door. Now see the component has changed. It is not a solid cylinder anymore. It is hollow inside. So what it's going to do is first it's going to pick up the object, finished object. Then it's going to place the other object, come out, close the cell again. So this is one more project. So some of I'll show you. So this is biscuit handling. So you can see in one arm, in one conveyor belt, you have biscuits coming in. On the other belt, you have cups. So sorry, handlers. So what happens is the biscuits are being picked and placed inside. This is using IRB 360, which is a parallel robot, guys. Similarly, I would like to show you a couple more. So this is while filling what we have done, what our students have done. While filling means, you'll have medical vials, right? Penicillin injection, all the vials. Okay, you have to fill in the inside, fill the drug inside that vial. So using this, we are actually filling we're actually filling drug inside those vials. Okay, using a robot. This was actually an industrial project what we got. Similarly, I would like to show you sandwich cutting. This was a fun project what I've done. Just for fun project. So you have sandwiches coming through, cutting into 4 slices and sending them away. Every time a sandwich will be coming in, you will be cutting it and it will be moving ahead. Okay. Similarly, yeah. This is automatic screwing system, guys. So this robot, what you're seeing is a SCARA robot, selective compliance articulated robot arm. Okay. So this is a SCARA robot performing nailing operation. So you can see nails being delivered here. Okay, so all these are possible only in Robot Studio, guys. And along with that, some more crazy projects you can think about. Okay, like a production plant where you can automate the medicines delivery of medicines. Similarly, you can think about F1 pit stop. Okay, pit stop is a entity in F1 race where if a tire is getting screwed up, okay, it has to be removed and replaced within seconds. Okay, so here we try to automate that using robots, and the entire simulation was developed in Robot Studio. So these are all the things Robot Studio can do, guys. That is the power of Robot Studio, and there's a proprietary software. Okay, so any doubts, guys, so far? And the programming language we use here is called Rapid. The program. So this is a sample. This is a sample program. What you're seeing over here. Okay, and this is the program which is being generated automatically in the backend. Okay. So these are some simulations, guys. See, some more simulation I would like to show you are, this is a seat assembly which we created for a bus company. Okay, you can see seats at the ground. The robot will actually try to pick up those seats and it will place it on the cabin. So that's the thing, guys. Any doubts so far, guys? Any thoughts? Any questions you have for us? Before we jump into Robot Studio, any questions you have for us? Speak out, guys. I'm not your enemy. You can speak out. Any queries, any thoughts, any suggestions you're getting into your mind? Anyone? Okay, so what's the status of installation, guys? Have you installed? Can you please ping in the messenger? What's the installation status? Students, can you please ping in the message box about the message installation status? Okay, Ashwin has installed. What about others, guys? Installed. Great. Others, can you please update the status? Vishwajit, no prerequisites, dude. Everything we can start right away. No need to know anything. I hope I've clarified your question, Vishwajit. Great. Others, please update. Let me share my screen. So everyone, let us see. Once you install Robot Studio, you will have two problems. Okay, not two problems, two milestones. I'll put it in a positive way. You will have two milestones. Okay, you will be having two milestones. Okay, great, Satvik. The first milestone I'll show you in the notepad. The first milestone would be okay, this is the notepad. The first milestone is activating trial license. The second one is installing robotware. I hope you can see this clearly. See, generally, guys, Robot Studio is a proprietary software. Okay, Robot Studio is a proprietary software, and it is completely developed and owned by ABB Robotics. Okay, so since it is proprietary, what ABB is doing is they are giving us 30 days free trial. Okay, within these 30 days, you are open to use ABB Robot Studio with its full extent. Completely, every functionality in Robot Studio you can use. So the first challenge is activating the license. Okay, the second one is installing robotware. Let me show you how to activate trial license. Okay, I'll just. Okay, somebody has pinged. Done, sir. Satvik, great. Others keep pinging whether if you have installed. So I'm going to my start. Okay, let me just. So first one, activating trial license. I'll show you how to do it. Please pay attention, guys. ABB. Okay, I'll just go to my start. Okay, we don't need this anymore. We don't need this anymore. So here you have here you have Robot Studio 2022. Okay, so I'll click on that. It will start opening. So let's wait for that. It's a high graphics tool, so you have to pay. You have to be patient. So first one I'm about to show you is uh, Robot Studio, how to install the trial license, activate the trial license. Remember, guys, it will be only there for 30 days, not more than that, not less than that. Exactly for 30 days. So make sure you're connected to internet, guys. Make sure that you're connected to internet, everyone. Because while activating trial license, it will be connecting to Robot Studio server. Meanwhile, everyone, please update your status whether you have installed or not. Everyone. Satvik, Vishwajit, there are few people who have updated. Others, please update the status. So this is my Robot Studio, guys. This is my Robot Studio. It has been activated for trial. If you want to see whether your system has been activated for, guys, please pay attention. From here, every step is very, 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 very crucial. The first one, as said, I'm going to teach you how to activate trial license. Okay. So first, to know whether your system is having trial or basic, here you have few options: new, open, print, share, help, online help. Please go to help, guys. Everyone, please go to help. In help, you have some support structure. Robot Studio homepage, tutorials, development center, and so on. But on the right hand side, if you go to license, if you go to the bottom, you can find the status of your license. There are three status, guys. The first one is basic, means without license you can operate Robot Studio. Very, 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 very basic functionalities. Okay. The second one is trial. The trial will be existing for 30 days. You can see here. My trial license is still 21st April 2023. The third one is premium. Okay, premium now you can use all the features throughout your year, throughout the year, or if you have lifetime license, you can use it through lifetime. Okay, so that is how you can use it. Remember, it has mapped your machine also. This is the machine, this is your machine ID which it has created. So you have to be very, very careful how to use and when to use. So this is about this is about the status. Currently, if you haven't activated the license, it will be showing you as basic. Now, if you want to activate the license, go to options. Everyone, go to options. Options. It will load, 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 and load. Please go to options, everyone. In that, click on the second option called licensing. Any doubts so far? Click on the second option called licensing. So this is my options. Here you have various options. You can select the language, color, theme, size, blue, whatever you want, you can select here. If you want to zoom the windows, you can zoom it. Then you have an option called licensing. Okay. Now by default, when you open, I'm sorry. By default, when you install Robot Studio for the first time, it will ask you whether you want to install the license or not. You have to select the option. I can click on activation wizard. This is the option. This is the window that will be coming to you. This is the window that it will come to you. Here you have to click on I want to request a trial license. I want to request a trial license. This is the option we need to use. Okay, guys, am I audible? Am I loud and clear, guys? Can someone please respond? Anyone, can you please respond? Am I loud and clear? Yeah, thank you, Sudarshan. So this you have to use this option called I want to request a trial license. Once you click on that, it will show you what are the possible parts of Robot Studio you can activate. You can click on that and click OK. Your license will be activated automatically. You just need to restart your Robot Studio. Once you restart, to know whether you have installed it properly or not, if you have activated it properly or not, you can go to help. It will be showing you trial along with the expiry date. Any doubts, guys? You want me to show it once again? Anyone, any doubts? Do you want me to show it once again? Please respond, guys. Please respond. Is it clear how to activate license? Is it clear how to activate license, guys? Please respond. Guys, I would appreciate if you are able to speak. Okay. Okay. I'll just explain you for the sake of the other students. Okay. If you want to open, if you want to install license, okay, go to options, licensing, activation wizard. Here you can click on I want to request a trial license. I want to request a trial license. Once you click on that, click on next. It will show you what is the Robot Studio offer available. You can click on that and click on generate license. That's all. Your license will be generated. You have to restart Robot Studio to apply that. That's it. Okay. Upon doing that, you can see here it will be available whether you have installed or not. So this is the first challenge, guys. This is the first challenge, activating trial license. The second challenge is installing robotware. What do you mean by robotware, guys? You guys are CSC engineers. You know what is software, right? You know what is a software. Okay. Similarly, any robot, okay, inside the robot, it needs a certain set of software systems or firmware to run the robot perfectly as the company designed. Such a tool is called firmware. In this case, we call it robotware. Okay, a firmware used in a robot is called a robotware. So I'll tell you how to install that. Please pay attention, everyone. Okay, go to add-ins. You can go to add-ins. Add-ins. You can go to add-ins. Here you can go to robotware. Robotware. You can click on robotware. You can click on robotware. Now, the robot, the controller means the computer that is actually performing the operations for is called IRC5, Industrial Robot Controller 5. You can select that. And for me, I've already added. If you want to add, you can click on, instead of remove, you will have an option called add. You can click on add. Any doubts, guys? I'll stop here for a minute. Any doubts? People, any doubts? I'll stop here for a minute. Any doubts? Do you have any queries? Please speak out, guys. Can one of you share your screen so that I'll help through your screen? Anyone who newly installed? Anyone, Yashwin or Sudarshan or anyone who have newly installed? Satvik, Vishwajit, is it done? Are these two steps done or you want me to teach through your system? Anyone? Yashwin, are these two steps done for you? Yashwin, are these two steps done for you?
Installed already, sir. One.
Huh?
I installed this long back, sir.
Okay, okay. Sudarshan, Satvik, what about you? Satvik? Okay, great. So I hope everyone has finished these two steps, right? I hope we are good to go. I'm explaining again, guys. Robotware is the system which will actually run your tool. Okay, which will run your robot. Okay, that has to be installed inside your controller. Okay, when you have an actual robot, you have to install it inside your controller. To do that, you can go to add-ins. Okay, here you can select robotware. You have many components over here. Here you can select robotware. Here click on robotware for IRC5. You have only two options, robotware for Omnicore, robotware for IRC5. Click on IRC5 and click on add. So Vishwajit, in your system it's not getting activated then. Did you already install this in your system? Then it won't work. It will work only once for 30 days. The trial will be maximum active for 30 days, guys. That's it. Okay, so I've already done this. So let me go back to my home, go to file. So shall we start, guys? Are you guys ready? Shall we start, everyone? Great, Sudarshan. Thank you. That's a good thing. Okay, let us start with Robot Studio, guys. I'm going here. The first and foremost option. Go to new, everyone. Go to new. Here you have various options. Yeah, see, either you can create an empty station. Empty station means nothing. You will have a plain station. Okay. Above project means it will be coming to you as a complete project. So click on create an empty station. Click on create an empty station and click on create. Click on create. So we were talking about the empty station. This is the empty station, guys. This is the empty station. Some controls, if you press control left key and drag, you can drag the tool. You can drag the station. If you want to rotate, control shift rotate. Control only control, you can pan. Control and shift, you can rotate. If you want to zoom in, scroll out. Any doubts? I hope you don't have any doubts. Any doubts? Let me just share my window. So, sir, where are the robots, sir? Simple, guys. Okay, I'll just hide this little bit. Okay, I'll just, yeah, this is better for me. Okay, so where are the robots, sir? First, guys, good. Top, you have few options: home, modeling, simulation, controller, rapid, add-ins. Rapid is the rapid programming language. Controller is the IRC5 virtual controller. Simulation, modeling, home. Please go to home, everyone. Please go to home, everyone. Please go to home. Click on ABB library. Click on ABB library. Please go to ABB library, everyone. Go to home. Under home, you have an option called ABB library. So these are various robots, guys. IRB stands for Industrial Robot Body. Please go to ABB library. Let us start with our first robot. Okay, sir. Sir, what kind of robots are there, sir? You have all these robots are called articulated robots. Articulated robots means all the joints are rotary in nature. Okay, for example, human arm is articulated, means it has only rotational joints. There are two types of joints, guys. Okay, translational or prismatic or rotational joints. Okay, sorry, prismatic or prismatic means it can move in a straight line. You can translate, you can stretch, okay, in XYZ axis. Some examples of prismatic robots are 3D printers. Okay, so that is translational prismatic. Revolute means you can rotate or revolve. Got it? So though if at all a robot has all the joints as revolute, such a robot is called articulated. So then we have painting robots. We have collaborative robots. Okay, here you can see CRB 15000 Gofa, Swifty, Yumi. Then you have parallel robots, IRB 360, 365, 390. Then you have SCARA robots. You would have seen in your classes all these robots. Then we have painting robots, tracks, and many more. Okay, let us start with our first robot, guys. IRB 1520 ID. IRB means Industrial Robot Body. IRB stands for Industrial Robot Body. On your right hand side, on your left hand side of the screen, you have three options: layout, paths and targets, tags. The first one, layout. Under layout, you can see the robot name you brought in. IRB 1520 ID 4152. Please finish it till here, guys. Next. I'll just show you 3-4 operations, then we can see the other part. Go to import library, everyone. Import library. This is an arc welding robot. So let us bring an arc welding end effector. So go to equipment. Here click on, let us take a welding gun. Let us take AW gun, means arc welding gun, PSF 25. Okay, this is the welding. I'm bringing it again for you. Go to import library, equipment, scroll down to tools. Here you have an option. Here you have many end effectors. Let me bring arc welding gun. Okay, now if you want to attach this arc welding, you can see the arc welding gun is here at the world origin. It is present over here. Now if I want to attach it, okay, some gentleman came so early to the class. Yeah. Now if I want to attach it, if you want to drag it, guys, I'll show you one way to drag it. This is your arc welding gun. Go to layout, arc welding gun. Then come back. Go to home. Under home, you have an option called freehand menu. Freehand menu. In that, you have 6 options. The first option is called move. Click on that, select it. So this is my arc welding gun. This is my arc welding gun, which I can move however I want. Okay, this is my arc welding gun. Sir, the next operation is to attach this gun to the robot. How shall I do that, sir? Simple. Right click on arc welding gun, go to layout, which is on your left hand side. Right click on the mechanisms, you'll find arc welding gun. In that you have an option called attach to. In that select the robot name. These are individual links. Okay, I don't want individual links. I want to select the robot. Click on that. Okay. This is my robot with end effector. This is my robot with end effector. Students, any doubts? Till here, any doubts? Please let me know, guys, so that I'll know whether we have to move forward or should we wait. Okay, great. Others, Vishwajit, Satvik, any doubts? Okay, no problem, Satvik. I'm just showing you again. Let me create this for one again for you. I'll just delete both. Okay, go to ABB library, go to home, ABB library. Here, bring any robot of your wish. Okay, let's say I'm bringing IRB 1660, or let's say I'm bringing IRB 2600. 12. It has a payload capacity of 12 kgs, reach of 1.65 meter. Click on OK. So this is my robot. Okay. So let's say I want to add a end effector. Go to import library, equipment, scroll down. This time let us add ABB smart gripper. Click on that. Any servo one vacuum can anyone. Okay. See, by default, every component will go to its home position, which is the origin. Okay. So this is the gripper, which is present at the bottom. So I want it to attach to the robot center. Sorry, to the end effector, to the end pointer. Okay. So to do that, right click on the gripper, attach to. Here you have various options. Click on IRC to IRB 2600 12 165C01. 12 na 12 kgs payload. 1.65 na 1.65 meters payload. Sorry, reach. Okay, click on that. Do you want to update the position of smart gripper? Yes. So this is my gripper. Clear, guys? Anyone? Girls and boys, any doubts? Shanmugavel, Bradeshwar, Yashwin, Lavanya, any doubts? Great. Okay, Samuel. Others? Okay, so let's move on, guys. Okay. Now, if you want to jog, see, guys, in nature, okay, generally, what do you mean by jogging, guys? English meaning jogging. What is the English meaning of jogging? Any thoughts? Speak out, guys. You guys are great kids. You are responding well. Speak out. What do you mean by jogging? Anyone? Any thoughts? Yashwin, Lavanya, Session, anyone? English meaning of jogging. That's it. Okay. Jogging the robot means jogging. English meaning of jogging is just moving, not just moving your body from one position to another position, not running. Again, jogging, because in the speed during jogging is very very less. So if at all, even if you hit someone, you don't see a great impact. Exactly, Lavanya. Exactly, Samuel. You will be moving slowly. Got it. So so here also jogging now. We can move individual joints of the robot one by one, or we can move the robot in straight line path the way you want. Got it? So that is what you mean by jogging. Slowly moving the robot joint by joint, or moving the robot in straight line. That is what you mean by jogging. So let us jog the robot. To jog the robot, I think I like the arc welding gripper. Let me bring arc welding gripper. Okay, just equipments, arc welding gun. I'll just drag and drop. So this is my arc welding gun. So if you want to jog the robot, guys, you have two options. Go to freehand menu, select the robot, go to freehand menu, everyone. In freehand menu, you have around 7 options. The first option is move. Don't move anything. Don't click on that. Moving now if you want to move an object. The second option is rotating if you want to rotate an object. Third one is dragging. Fourth option is jog joint. Means jogging the robot joint by joint. Sir, what are last 3 options, sir? The what do you call fifth option is jog linear. Means if you want to jog the robot in a straight line, I'll show you how. That is disabled right now because we didn't import the controller. Next, sixth option is jog reorient. Seventh option is jogging multiple robots at the same time. I'll show you how. Don't worry. Okay. So this is my robot. Okay, this is my robot. If you want to jog the robot, first go to layout, everyone. Under mechanisms, you will find your robot name IRB 2600121165. Expand that. You will find links. Expand that. Here you can see link wise you can see where is it situated. Okay, now if you want to jog the robot, select the robot, turn on jog joint, now you can select that particular joint and jog it. You can jog it link by link. Right now I'm jogging first joint. So for the first joint, the the maximum it can go is minus 180 degrees to plus 180 degrees. Okay. Secondly, the second joint is here. The maximum limit is 155 degrees to minus 95 degrees. Okay. Third, this is the joint 3. The maximum limit is 75 degrees and the minimum negative limit is minus 180. So it can rotate, you can jog the robot from minus 180 degrees to plus 75 degrees. Okay. Then we have fourth joint. The negative limit is minus 400 degrees and the positive limit is plus 400 degrees. Okay. I'll just bring it slowly. Okay. The fifth one is here. Okay, fifth and sixth one, you can rotate it like this. Sixth one. This is fifth joint, up and down. So this is how you can jog the robots. If at all your robot is in an awkward condition, if you want to bring it back to home position, right click on the robot, go to move to pose and click on jump home. Okay. Any doubts, guys? Any doubts here? Any doubts, people? Again, I'm explaining. Go to layout, select the robot name. Fourth option, you have jog joint. Click on the joint and drag it. Okay, if at all the robot is in awkward condition, if you want to bring it to home, let's say your robot is like this. If you want to bring it to home position, right click on the robot, move to pose. Sorry. Right click on the robot, move to pose, jump home. Okay, guys. Any doubts? Any doubts, guys? Okay. Session, Samuel, Lavanya, any doubts so far? So, guys, now let us come to the serious stuff. Okay. If you want to enable higher functionality for your robots, okay, you have to import something called virtual controller. You have to import a virtual controller. What is a controller, sir? Virtual controller is a computer. Okay, it is not one single computer. A virtual controller, imagine that to be a single door refrigerator. I'll show you how it's going to be. It will be like this. Import to library, equipment. Here you have an option called IRC5 single cabinet controller. So This is a ABB controller, guys. This is the controller. Inside this controller, how it's going to be, I'll show you. I'll just go to Google and I'll show you. ABB IRC5 C5. Okay, so how it's going to be inside? This is how the controller is going to be inside. Okay, I'll show a better image. Yeah. So this is how the controller is going to be. Inside the controller, you have one control module, then you have 6 axis computers. 6 axis computer. Now each computer is for one robot. Sorry, one joint. If a robot has 6 joints, then you will have 6 axis computers. Each axis computer will be calculating the joint angles. All the mathematics part will be done in axis computers. Okay, so this is how the real IRC5 is going to become. So inside, this is nothing but a system where you have multiple computers, okay, calculating the robot kinematics. You would have heard about forward kinematics and inverse kinematics. So that is being done here. Okay, so let me go back to Robot Studio. So this is just a model, guys. If you want to give that functionality, please go to, now please pay attention, guys. I'll go here slowly. Go to home, everyone. Go to home, everyone. In home, you have an option called virtual controller. Virtual controller. Virtual controller. In that, you have an option called from layout. What does it say? Create a virtual controller based on the existing layout. This is the layout, guys. This is the layout. In this layout, we have IRB 2600 robot. So what it's going to do is, it is going to create a virtual controller based on the robots present in this layout. So from layout, so my controller name is controller 2, or let's say I'll name it as Sathyabama controller. Okay. Now this is the location of the controller. This is the robotware which we just installed. Okay. Then click on, I hope you can see the screen. Yeah. Then click on next. It will show you what are the robots available. Currently I brought only one robot. So only one robot is available. Make sure it is selected. It is selected by default. Then click on next. It will give you a short summary. What is the controller name? Sathyabama controller. What is the media? ABB Robotware. Version, options, whatever is selected, it is present over here. Click on finish. Click on finish. Here you can see a green line passing, means the controller is being connected. You will have 3 phases, guys. First it will show you red color. Red color, so now currently see the status. Red color 0 by 1. 0 by 1. See, these options are not activated. The moment it turns green and the status is 1 by 1, the controller is connected to the robot. The controller is connected to the robot. It means all the calculations now can be performed on the virtual controller. Okay. Please just do this setup, guys. Do this thing. While it's loading, please do this. Any doubts? It is loading. It will take some time. Any doubts, guys, so far? Guys, I hope so. This is the status, guys. Right now, this is the status. Okay, you can see the state controller status here. Earlier, it was not connected. Okay, earlier it was red color, status was 0 by 0. Sorry, 0 by 1. Now the status is green color and the value is 1 by 1. It means the controller has been connected to the robot. Now you see these options. Now these options are activated. That's the beauty. Okay, now these options are activated. Okay, now let us perform some jogging, guys. Okay, before jogging, I want to explain few things to you. Okay, we often see this is stationary. The robot is stationary. Okay, now it cannot move more than that. So where should I place the object? I should place the object uh, within the vicinity where the robot can reach. How do you know that? Okay, that is that is what we call uh, work envelope. To open the work envelope, go to layout. Go to layout. I don't know who's coming so late. Go to robot. Go to the layout. Right click on the robot. Right click on the robot. Right click on the robot. You have an option called show work envelope, guys. You have an option called show work envelope. Show work envelope. Show work envelope. Please click on that. So what you see right now is a 2D outline, guys. This is the 2D outline. Means this is how far the robot can move. Beyond that, the robot cannot move. If you can see this, see, this is how the robot can move. Okay. So this is the arc made by the robot. No, sir, I don't want 2D, sir. I don't want the line. I want the 3D, sir. Then you have an option called 3D volume. You have an option called 3D volume. So this is the entire space. Volume, not three-dimensional. This is the entire space where the robot can reach. Now tell me one simple question, guys. Where should I place the any object within this or away from this? Tell me where should I let's say I have an object. Let me create some object. Okay, I'll go to modeling, solid, box. I'll have a height of let's say I'll have a height 500. No, let's say I'll have 800. Okay, I'll create an object. Now tell me where should I place this box? Where should I place this box? Speak out, guys. That's a very simple question I'm asking. Tell me where should I place this box? Can I place it? Oops. Where shall I place this box? Should I place it here or should I place it here or where should I place? Come on, tell me, guys. Where should I place this box? Any thoughts? Speak out, guys. Where should I place this box? I want to perform operation on this box. So where should I place it? Should I place it inside the work envelope or outside? Tell me, guys. Come on, guys. It's a simple question. Should I place this box inside the work envelope or outside? Outside, inside the work envelope. Okay, guys, outside means the robot cannot reach. For example, let me jog this. Okay, the robot only can reach till here. Robot can only reach till here. So what I have to do is I have to place this box inside the work cell. Let me just bring this robot to home. I have to place this box where the robot can reach. Okay, so this is what you mean by work envelope. Sir, why are we seeing this, sir? Whenever you are creating application, you need to make sure whether your object has to be placed within the reach. Clear? So that is what you mean by work envelope, guys. Next. Okay, now let me turn this off. Let me just go back to, I'll just show work envelope. I'll turn it off. Now check this out. Okay, let me just move the robot a little bit. Move the robot here. Okay, now see. Now the next thing is, sir, I want to jog the robot in straight line, sir. In that case, you have an option called jog linear, guys. Jog linear. Click on jog linear. You see, you can jog. Now see, please pay attention. The moment you click on jog linear, you can actually drag the entire robot in 3 dimensions. X, so this is Y. You have the reference here. This is Y. Then you have Z. Wait. Then you have Z. Then you have X. Okay. Then you have X. Clear, guys? So this is called jog linear, guys. This is called jog linear. If your robot is in awkward condition, just jump the robot to home. See, I'll show you the difference. Jog joint means you can jog joint by joint. joint 1, joint 2, joint 3, joint 4, joint oops, joint 5, joint 6. Jog linear means you can jog the robot in a straight line. The TCP, this point is called TCP or tool center point. Okay, this point, right, this tip which actually touches the application object is called TCP, tool center point. So what the robot does is this TCP has to go in a straight line. The entire robot will be moving along in the along all the joints will be moving to compensate that. So this TCP or the end effector will be moving in straight line. See this. This is jog linear. Jog linear. Jog linear. Okay, then you have an option called jog reorient, guys. Jog reorient means this point in space is going to be constant, that is not going to move. Okay, the entire robot will move about that point, this space, this point, this TCP, the position of the tip will be same, but the robot will rotate about that. For example, see the beauty, entire robot is rotating about that point. Entire robot is rotating about that point. Sir, why is this important, sir? Because our point in space can be reached in infinite. There are infinite solutions to reach a point in space. I can come here like this, I can come like this, like this, like this, like this, many ways. Okay, so for example, if I'm moving like this, suddenly when I'm coming like this, one of my joints has reached the limit. So instead of still traveling like this, what I can do is I can go like this. So the same space is being reached in a different orientation. This is called reorient. Reorient. See, the point is constant. The point is constant. The entire robot is rotating about that. Clear? That is jog reorient, guys. Okay. Any doubts, guys, so far? Okay, guys, people are requesting for a break. Take 10 minutes break, guys. Right now it is 11:05. We'll join back in 10 minutes, guys. 11:15 we'll meet again. Okay, thank you.